In this video, we are going to find non-negative integers a, b, and c such that 2 to the power of a times 3 to the power of b plus 9 equals c squared. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. I'm going to first check whether a or b can be equal to 0. I'm not going to do that for c because we know that 2 to the power a times 3 to the power b is always a positive number. When it's added by 9, it's also positive. So c, given that it's non-negative, it can only be positive. So if a equals 0, then the equation becomes 3 to the power b plus 9 equals c squared. So c squared minus 9 equals 3 to the power b. C plus 3 times c minus 3 equals 3 to the power b. So we factorize, and we know that c plus 3 and c minus 3 can only be powers of 3 or 1. So we say c plus 3, c minus 3 is equal to 3 to the power x or 3 to the power y respectively, where x and y are integers that are non-negative. Then subtracting, we have 3 to the power x minus 3 to the power y equals 6. And the only solution for that is x equals 2 and y equals 1. From this, we know c equals 6 and b equals 3. So for this case, the solution is 0, 3, and 6. That's the first case. Next, we can check when b equals 0. And using a similar argument, we have 2 to the power a plus 9 equals c squared. And again, the product of c plus 3 and c minus 3 is now power of 2. So I'll let each of these two expressions are equal to some power of 2 again. Then the difference of these powers of 2 is equal to 6, and the only solution for that is x equals 3 and y equals 1. From that, we have c equals 5, and so a equals 4. So another solution is 4, 0, and 5. So this is what happens when one of the unknowns is equal to 0. Next, I'm going to focus on solving this equation on positive integers a, b, and c. Now if a and b are both positive, then 3 to the power b must be multiple of 3. And so same for the whole term, 2 to the power a times 3 to the power of b. And that means c squared would also be a multiple of 3. And that means not c squared, but c itself is also multiple of 3. But then 9 will divide c squared. So 9 not just divides c squared, but also divide that number minus 9. And that equals to 2 to the power a times 3 to the power b. So if we assume that b is positive, then b will be at least 2. So then I'm going to let c equals 3k, some positive integer k. And then I can say 2 to the power a times 3 to the power b plus 9 equals 9k squared. And we can divide both sides by 9, and we have 2 to the power a times 3 to the power b minus 2 plus 1 equals k squared. Or if I move 1 to the other side and factorize, we'll have k plus 1 times k minus 1 equals 2 to the power a times 3 to the power b minus 2. Now, after making use of the fact that b is positive, I'm going to also make use of the fact that a is positive. So this, we know that the product of k plus 1 and k minus 1 have to be even. So either 1 of k plus 1 and k minus 1 have to be even, and both cases imply that k has to be odd. Then I can say let k equals 2p plus 1, some integer p that is positive. We know that if p is 0, then the number k will be equal to 1. So the product at the left, k plus 1 and times k minus 1, will be equal to 0. But that cannot happen. So I just reject the case p equals 0 straight away. Now from this, I can say this 2p plus 1 added by 1 multiplied by that minus 1 is equal to 2 to the power a times 3 to the power b minus 2. Then at the left, we have 2p plus 2 times 2p. So actually, I have a multiple of 4 at the left. From this, we know that, again, a has to be at least 2. So then the right will also be a multiple of 4. Then divide both sides by 4 again. We have p times p plus 1 equals 2 to the power a minus 2 times 3 to the power b minus 2. Now the interesting fact is, because p and p minus 1 are consecutive integers, or consecutive positive integers, that means they are co-prime, as in they do not share any common prime factor. So that means each of these terms, p and p plus 1, have to be a perfect power of 2 or 3, or one of them has to be 1, and then the other expression takes all the factors. So, two cases. Either p equals 1, clearly the smaller one, or p is a power of 2 and p plus 1 is a power of 3, or it's the other way around. P is the power of 3 and p plus 1 is the power of 2. The first case is easy, because we know that p is equal to 1, then p plus 1 equals 2. So that means a has to be 3, because a minus 2 equals 1, and b equals to 2. Then from this, we know 2 to the power of 3 times 3 to the power of 2 plus 9 equals c squared. And the left, after calculating, is 81. So c equals 9. So this case gives 3, 2, and 9. A very simple case. For the other two cases, that means the perfect powers 3 to the power b minus 2 minus 2 to the power a minus 2 equals 1, or 2 to the power a minus 2 minus 3 to the power b minus 2 equals 1. To make calculations faster, I'm going to make use of the Catalans Conjecture, which says whenever we have two perfect powers with difference equal to 1, unless one of the two or the both exponents are equal to 1, the only solution would be 3 to the power 2 minus 2 to the power 3 equals 1. So we can bring this to our two equations over here. Either we have these exponents to be equal to 1, then we can have b minus 2 equals 1 and a minus 2 equals 1 over here at the equation at the left. Or for the equation at the right, we can have a minus 2 equals 2 and b minus 2 equals 1. Otherwise, the only possible case would be b minus 2 equals 2 and a minus 2 equals 3. And that's it. That's all the possible solutions. So for each case, either we have b equals 3 and a equals 3, b equals 4 and a equals 5, or for the case at the right, we can have a equals 4 and b equals 3. Then we can solve for C case by case. For the case when both a and b are equal to 3, then we have C to be equal to 8 times 27 plus 9, and that's 225 square root, so C equals 15. When b equals 4 and a equals 5, then we can do some calculations. So 2 to the power 5 times 3 to the power 4 plus 9 is equal to 32 times 81 plus 9, and that's 2601. So that means C equals 51. Finally, for a equals 4 and b equals 3, we have 2 to the power 4 times 3 to the power 3 plus 9 equals 16 times 27 plus 9, and that's 441. So in this case, C equals 21. So putting all the cases together, here we have 3, 3, 3, 15, 5, 4, 51, 4, 3, 21, and the one over here, 3, 2, 9, as well as the cases above. Zero, 3, 6, and 4, 0, 5. These are our final answers. Please feel free to share ideas in the comments. Thank you for watching. See you next time.